3 tick marks, 1 tick mark, 1 tick mark. So the sides match. And then we also, oh, thank you. We also added in like the piece on the inside that was congruent. So the perpendicular bisector is the non-highlighted part. Where if you use your eyeballs today and you look at the bottom of the triangle, does it look like, because they look similar, but does it look, if you look closely, does it look like the bottom is being split in half?
Oh.
No, because it's not. It is not perpendicular bisectors, it's angle bisectors. And that's why on each angle, we have 1 tick mark, 1 tick mark. So those angles match. This one has 2 tick marks, 2 tick marks. So those angles match, meaning they're being split. This one is 3 tick marks, 3 tick marks. So it's being split. So they're 2 congruent pieces. So this is created by angle bisectors. Which the angle bisectors we're going to put in the picture, or we're going to write out. AM is an angle bisector. AM. Another angle bisector would be CM. It's going from the corner in. CM is an angle bisector. What would be the last one? BM. So they're splitting the angles. And then last time we highlighted them, the little angle piece, the like where it looks like an angle bisector, but it wasn't an angle bisector yesterday. These ones are not congruent. Using your eyeballs and a little bit of common sense, this one looks like it's longer than this one. They are not the same today. So yes, they look very similar, but this is angle bisectors. This part is not the same. The bottoms are not the same. What we're going to do is we're going to fill out this little part and we're going to highlight our new important part. So the incenter is technically equidistant. So equidistant. Once again, we're going to highlight that word equidistant from each side of the triangle. Yesterday was from the vertice, so we highlighted to the corner. Today, it is not the same. Today, it's going from the center, which in this case is M, and it's going straight down to the bottom. So this piece is congruent to this piece, which is congruent to this piece. So if you look at your picture, it looks like that. They look like they're the same length. So not only are we going to highlight it, but we are also going to put a tick mark. Tick mark, tick mark. So we're going to say MZ is congruent to MY, which is also congruent to what? MX. So they look very similar, but notice that the markings are in different parts. There's more markings that we're going to add to this picture that actually don't have it listed for some reason, but we're going to add it anyways. So once again, yesterday split each side. So the sides were split, sides were split, sides were split. If you notice, the bottom is not being split now. But what is happening is, because this is also from Monday 14th, this is the angle bisector. The pieces across from each other are the same. So we're going to put 2 tick marks here, 2 tick marks here. So these are not the same, but these are the same. We're going to do 3 tick marks here, 3 tick marks here. So it's not splitting the base. It's actually matching on the other side. And then the last one at the top. So these are kind of like party hats, I guess. 1, 2, 3, 4. 1, 2, 3, 4. So it's not splitting at the base. It's splitting across like the same that matches across. Ooh, nice. Okay, so we're going to go to this piece of paper. So we're done with this one. Monday, we're going to do a practice day of both of the ones that we've talked about this week to refresh your brains, because I know your brains are small and they don't remember things. And then we're going to do the last 2 next week. So on this piece of paper, this is number 55, and I'll show you the table of contents later. So the incenter is made by angle bisectors. Angle bisectors. And where the angle bisectors actually touch, where they come together, is the incenter. So the incenter is smack dab in the middle. Boop, boop, boop. For the point P. The incenter is always equidistant from the sides of the triangle. So going straight down to the side, straight down to the side, straight down to the side. So those pieces are congruent. So from the side of the triangle. So we're going to list the angle bisectors, which is the line that's actually splitting the angle in half. So if I'm looking at this angle right here, the line that's actually cutting it in half, which that doesn't even look like it's in half, but it's supposed to be, whatever. We're going to say A to P is the angle bisector because that's what's splitting it. What's another angle bisector in this picture? I think somebody just mumbled it. What did you say? BP. BP starts at a vertice and goes straight to the center. What's the last one? CP. The incenter is where? P. And then we're going to list all the congruent segments, which are the pieces on the inside. So we're going to start with what we highlighted. We're going to put one tick mark here, one tick mark here, one tick mark here. So DP is congruent to EP, which is also congruent to FP. So they all match. We also have other things that we're going to add that are not mentioned on the picture. The first one we're going to do the smallest triangle at the top because I don't want to put 4 tick marks up here. So I'm going to put 2 tick marks here. BD is congruent to what? Not CF. BE, because they're on the opposite side. So BE. The next one I want to do is C to E. CF. Nice. 1, 2, 3. And then the last one are the longest two. It kind of looks like a party hat. Party hat. Okay, they're the same. So party hat over here. 1, 2, 3, 4. 1, 2, 3, 4. So last one's AF matches what? AD. I don't know why. That's not cute. So the only pieces that are not congruent today, so yesterday's only pieces that were not congruent were the pieces that are actually highlighted today. Today, the parts that are not congruent are the parts that actually go to the vertices. So yesterday, to the vertices were congruent. Today, to the sides are congruent. So they look very similar. So it's like the same thing, just a little different. So let's go to number 4. So, oh, it should be number 1, whatever. So P is the incenter of triangle JKL. We're going to start by moving our numbers around just like we did yesterday. So let's start with the outside. 17 can go where? NK. Because if you use your eyeballs and common sense, this is not the same as this. This one is definitely shorter. So these are not the same like they were yesterday. These are the same. There's nothing else on the outside. So let's look at the inside. We have an 8 and we have a 13. Let's start by highlighting our incenter. So our incenter is P. And we're going to go straight out to the sides. Straight out to the sides. Because once again, if you have a little bit of common sense, if you look to the corners, to the corner, to the corner, to the corner, you should be able to tell that this is the longest. So they are not the same. The little short pieces are. So which number should I be able to move around? 8. So 8 can go here, 8 can go here. So take a second, see if you can fill in what you can fill in. Find NP, NK, PK, PO. See if you can fill in anything. Yes. Uh. So how much is NP? 8. How much is NK? 17. Now we got to find PK. Where the heck is PK? Oh, PK is here. PK does not have a number. PK does not have a matching part. So what are we going to have to do? Pythagorean theorem. So it doesn't matter which triangle you color because they both have 17. They both have 8. You're only coloring one of the triangles. So I'm going to do this lower one because it looks like my colored pencil kind of went more into the lower one. If you turn your paper, it might help your eyeballs to figure out where the numbers go on your little diagram. If I turn my paper, there's my right triangle. The bottom is 17. The height, the altitude is 8. I do not know the hypotenuse. I do not know C. So 8 is my altitude, which is the height. 17 is the base. I have to find C. So when you plug this in, the Pythagorean theorem is actually easier because it's not a subtraction problem. You're literally doing 8 to the power of 2 plus 17 to the power of 2. Yep, that's perfect.
Wait, after you get the answers, I don't get it.
Yeah. Yeah. Not x2, you square root it, which is a little bar thing where you shift square.
And then once you get the answer, you square root it, huh?
Yes. So we're doing 8 squared plus 17 squared. 8 squared is 64. I know that off the top of my brain. What's 17 squared? 289. When you add them together, how much do you get? 353. So we have to square root it. Oops. 18.78. So that 8 is going to go up to, the 7 is going to go up to an 8. So 18.8. When you find a piece of information, the whole point is for you to see if you could put it anywhere else in your picture because it's a puzzle. So I'm going to put 18.8. That's the hypotenuse. I'm going to put it actually in the real picture. And that 18.8 we moved around anywhere. So can 18.8 go anywhere else?
No.
No, because the hypotenuses are not the same. So 18.8 can go here. How much is PO?
Yo.
Yep.
8.
8. Nice. Okay. Try number 5. Start by moving around the outside. So where else can 6 go? EF. Good. Where else can 35 go? FC. Where else can 37 go? Nowhere. 37 is the hypotenuse. And if you have common sense, this is very, very long. It cannot go in the same spot on the other sides because they're smaller. So you can't move 37 anywhere. So that's all I got. GD. Oh gosh darn it. GD has literally nothing. So we're going to start by doing the Pythagorean theorem because GD literally doesn't have a number. That is the same. Technically, if I do my highlight my Incenter and I go straight out to the sides, all of these are congruent. So whenever I find it, it can go in all of those pieces. So if I'm trying to find GD, would it make sense for me to color in the left triangle or the right triangle? The right, because it has numbers. You can't color in the left because there's nothing over there. So I'm going to color in my little triangle. The hypotenuse is 37. 37. The bottom is 35. You have your right triangle. So in this case, this is a harder Pythagorean theorem from. Huh? Did we skip what? No. So this is where you're trying to find A or B. I'm just going to call it A because this is a subtraction problem. You already know C. So we're going to square them. And then you have to subtract. You have to minus because you have to isolate A. Oops. minus 1, 2, 5, whatever that number is. Ooh, this is nice. What do you get for this? When you square root 144. Well, that's nice. Because you have to, you tried to add them probably. This you already know C. C is 37, so this is a subtraction problem. So you're doing 37 squared minus 35 squared. So when you square root, you get 12, which is beautiful and gorgeous in Picasso. So that's the height, that's the altitude of the triangle. When I put it in my picture, 12 can move to a bunch of other places. 12 is here. 12 is also all the highlighted blue parts because they are all the altitudes of the triangle inside the triangle, because there's lots of triangles going on in this triangle. How much is GD? Well, how much is EG? 12.
35.
FC is 35. How much is BF?
Yeah, what's BF? Okay.
6. Okay. So the next one looks a little different because there's literally no numbers on the picture. And I know you guys love those. Oh my God. So it says S is the incenter. So we're looking at the inside. It's the incenter of triangle PQR. Shh, be quiet. It says M, little angle. So the measure of angle PRQ. Now we're talking about angles. So we're talking about the insides because it's the angles. So it says the measure of angle PQR is 8x minus 10. That's why it's got the little degree, because we're talking about degrees on the inside of the triangle. Is that much? RPQ is this much, and that is this much. Find each measure. So first thing we gotta do is put the stuff on the picture. So this is where you guys are, most of you are bad at. You have to read 3-letter angles. So we're looking at P. We're going to R, and we're ending at Q. So this is the whole angle because it's all the letters on the outside. When you look at these, technically they cannot just say R. They can't say R because R has 3 different directions it's going. It's the whole thing, it's this side, or it's this side. So that's why they use 3 letters. So it says PRQ. PRQ is R. It's focused on R because it's the middle letter, but it's the whole thing. So I'm going to put an arc mark here, and I'm going to put 8x minus 10 on the outside because it's the whole angle. It's not just one of them, it's both of them combined. So both of these together is 8x minus 10. I'm just going to stick it over there for now. The next one says RPQ. You're focusing on P, but P can go in 3 different directions. P could be the whole P, it could be half the P, or half the P. Well, no, it says R to P to Q. So it's both of these combined. So I'm going to put 2 marks because it's not the same as this one. This one's obviously fatter. It's wider. They are not the same. Okay. PQR is focusing on Q. PQR is also the whole outside. How many arc marks should I put here?
3.
3, because it's just like the next one in line. They're not all the same. We don't know they're the same. They're not telling us they're the same. So I'm going to put 3 marks. 7x minus 5. So I need to find each measure, meaning the amount. So what should I do with all of these to solve for x? What kind of equation? Yes, because a triangle equals 180. Not only does each small triangle equal 180, the whole thing as a whole equals 180. So we're going to add all of these. We're going to equal it to 180. So this is when we did this in chapter 5. Your equations start really massive. Massive.
Oh.
But when you combine like terms, it will reduce to a 2-step equation every single time. So we're going to combine the x's using addition. We're going to combine all the numbers, even if they're negative. We're going to combine them all using addition. We're combining like If I combine x's, how many do I get? 19x. And if I combine the numbers, no. Oh, negative 29, right?
Yeah.
Yeah. And then I add, then I divide. He said 11, but 11's the answer. 4x.
Yeah.
So when I divide, I get 11. Now, what do you think I'm going to have to do with x?
Wait. You gotta plug it in.
Yeah, gotta plug it in. So I'm going to plug it in.
That's how you get like the angle.
Mhm.
Oh, I'm smart.
Okay, now let's think about this. This is technically you have 3 angles and they're asking for like 47 million answers. Okay, so when we plug this in, 8 times 11 minus 10, how much is this one if I plug that in? 78. So let's think, let's use our big brains. If this is 78, the whole thing, and they're made by angle bisectors, how much is each side of this? Half of it. So what's 78 divided by 2? 39. So both sides of these are 39. Because there's a million answers, they're probably going to ask for some smaller answers as well. The next one's 4x minus 14. 4 times 11 is 44. 44 minus 14 is how much? 30. So how much is each one of those smaller angles? 15. So take a second, plug it into the last one, divide it by 2 to get each smaller one, and then see if you can read how they want to answer. Because it's focused on the middle letter. And maybe just outside letters too.
That's what you.
Well, it's the inside. Because of this is 6. That's the picture. Oh, right. It's like 6. Yeah. Plug it in. Divide by
Wait.
2.
What if it's R and it's still the same answer that I get for the P?
No. So this one, that's what we're talking about. Is like this one says P in the middle, but this one also says P.
No, but the first two that you can get them by plugging them in.
Yeah, so
right?
those are the big ones.
Yeah.
This is the smaller ones.
How do those?
Well, so you read it, so R, P, S starts at R, goes to P, ends at S. So it's really still focusing on P, but it's the skinny piece because it ends at S instead of ending at Q. So it's the skinny piece.
What do we do it?
So like it's 15.
Oh, okay, I did.
Get 15.
So like, because you
Oh, so
take
it's half
30
of
and
it?
you cut it in half. Yeah, it's half of it.
So it's literally half of everything.
Okay. Yeah.
Okay.
Right.
I'm keeping us. ESR? ESR. And then it would. Oh, it's no. Is it the? No, from German original. You add it.
Add it to what? Yes. Mhm.
Fine.
You can do it. Here, let's talk about the answers so far. So PRQ is the outside. That's talking about this one. So how much total is this one? 78, hopefully, right? Okay. The next one is focusing on P. It says RPQ. RPQ, that's the whole thing. That's 30. The next one says PQR. PQR is the whole thing. So that should be how much? 72. The next one says RPS. So yes, you're still looking at P, but you're starting at R and you're ending at S. So it's just skinny. So it's 15. PQS, P starts here.
36.
Q to S is 36. The next one's 39. And the next one, PSR, is focusing on S, which is on the inside, which is right here. How do you get it? Yes, because this is a triangle. Inside of a triangle, each individual triangle technically adds to make 180. So if you know that one corner is 15 and one corner is 39, you're just subtracting two angles from 180. So how much is it? 126. Oh, just 126. Nice. You got to start thinking outside the box. Everything starts applying together. Everything starts smushing together to make crazier pictures. But it's all the same math. Now that we've done all the easy stuff, it's just going to get harder because of multiple things all in one. Okay, we're going to go to the back and do one more. On the back, we're going to do one. We're going to do... Let's set up 19. 19 says find X. So the good thing is we just have to find X. We don't have to plug it in. Let's start moving around things. 19 has the bubble. So it's a degree. It's an angle. So 19 is not on the outside. It's on the inside. So where else can it go? Because it's an angle. On the other side, because it's an angle. It goes on the inside. It's a degree. Where else can 27 go?
Yeah.
On the other side, because it's an angle bisector. They match. Where else can 17x minus 7 go? Other side. It's just ugly, but it's correct. 17x minus 7. What should I do if they're angles to solve for x?
You add them all together and then, well, you add them to make 180 and you plug it in.
You don't even have to plug it back in. It just wants x.
Oh,
So we're going to add all of them together, everything, and equal it to 180. Geometry is like problem solving. So you could make this equation shorter by adding everything together like first. You don't technically need to write everything out doubled because you know it's doubled. But I'm going to write everything out. So I have two of those.
we're gonna add everything like
Yep.
everything.
Everything twice. Or if you're smart enough and you understand that you're doubling it, you could just
do it times 2 and then
Yeah. So this equation looks obnoxious, but when you combine like terms, your x's come together, it's going to be a two-step equation. X's come together, and then all of your numbers go together. Numbers go with numbers, x's go with x's. So you're just combining, you're adding like terms. Or you can think you're just doubling them out, make your equation shorter. Or you can once you find x, you're done. From now on to the next one. Okay. So the next ones are lines. So you're not adding to make 180 because they're not angles. What should you do with those two lines?
Oh, it's equal to each other.
Equal to each other because they're both on the same short piece on the inside. So they're just equal to each other. Mm-hmm. All three of them are equal, but you don't have
I don't have one.
yeah, you don't have one of them, but you can't even make an equation with another equal sign anyways. But if you're trying to find IK, when you set these equal and you plug it into one of them, that amount is going to go for all three angles or all three sides. So when you plug it into one of the equations, that's the answer because all three lines are the same length. So let me know if you get stuck. Keep doing. It's like a puzzle.